Anyone want to do number 1? Otis, you got it.
So first I circled the ones that wouldn't be a function because of the x values. So I circled the x values, and then I found that since there were no repeating x values in these other 2 tables, that those would be the functions.
Thank you. Good job. Anyone want to do number 2? I'll do number 2 just so we're not doing it twice in a row. All right. Is this a function? Yes or no? Why not? Go ahead, Otis.
Because the negative x repeats.
Which one?
On the negative one.
The negative, sorry. So because that negative 1 goes to both -7 and 0, that is not a function. You can say the negative 1 repeats, or the negative 1 has 2 different y values, either or, it does not matter. So for number 3, you had to remove 1 point on the graph so that it would be a function. Anyone want to do that one? Regina, go for it. Do we agree with Regina's choice? Yes. If we got rid of that 1, it would then be a function because now it passes the vertical line test, supposing that's not there. Yes.
You could do the other one, right?
Which one? This one? Yes, either or. So either of these points as long as you get rid of one of them. Right. The very last one. Anyone want to do that one? Otis, you could do that.
So these values of x, if it were to repeat any of these values, would represent it not being a function of
x. So for this one, it's asking for which one specifically repeats. So what are all the values of x that would result in this solution? And not the x, but if we put any of these back in for x, then it would not be a function. That's what it was trying to say. Right. Questions on any of these? Yes. Yeah. You could put them in the order that they're listed, or put them in least to greatest, either or. So, 1, if you've not done the recognized functions from a graph, Khan Academy, I know there are a couple of you that haven't done that. Make sure you get that done. From what I saw, it takes literally maybe less than a minute if you remember what we talked about. Before we start our notes for today, I just want to say that you guys did really well on the tests. So give yourself a pat on the back, a round of applause, because you guys did really well, and I'm proud of you guys. Keep that up. Make sure you keep practicing. That may have been just easier because you've done solving before, and then it was just more of that. But good job. Okay. So today and next class, we're going to be talking about domain and range. The pink sheet you have is where you're going to put all of your work. I would say probably do it put the orientation landscape flies. We're going to be using things on this paper first, so the one with the grid lines. So find that one first. We're going to be using this little foldable, so if you haven't already, you can unfold this square. And it should look something like this. When we cut out our graphs, we're going to put it in the middle of this until we get the hang of it, and then we may not need this. Okay, cut out the example. Make sure you have the X and Y axis. Hold on 1 second. And make sure it says the word example. Yes. It's on the pink sheet. Or, yeah, there you go. Alright, so go ahead and cut out the example graph. And you're going to put that in the middle of your foldable thing. Oh, yeah. No, not in here. Just cut it out. Don't glue yet. So the example one that matches mine. Yeah. The domain and range we're going to write right next to it, so we don't need that part. And once you have the example part cut out and put in your little foldable, look back up here. Some of yours may be a little too big for it, and that's okay. We're going to be folding it a bunch of times, so it's fine. So domain and range from last class is our X values, our Y values, but there's a specific notation that we have to write when it's not just a bunch of ordered pairs. If it's an actual function, we have to find the lowest and highest value for X and the lowest and highest value for Y. So for our domain, while it's in here, we're going to fold these sides. So fold one side to your y-axis. Fold the, sorry, I'm trying to do this and look at it at the same time. Fold the right side to your y-axis. So look like that. So I can do this up here, but it won't look exactly like yours. So your right side, fold it to your y-axis. Your left side, you're going to fold it to the furthest point on the left on the graph. So here, that would be right there. I don't have the graph in here, but it would look something like this, where you have some space in the middle. Again, I don't have the graph right here, but up here it should look the same. And we're going to count how far to the left did it go. So start at your y-axis, count back negatively. What would that be? Where did it stop? What's the farthest it went out to the left? Oh, it's 4. So it would be -4. So somewhere on your pink sheet, don't write too big, but we're going to write domain and range. The way the notation is set up is going to be using set builder notation, kind of like when we were doing our absolute value equations, but a little different. So write domain and range, and then you're going to start off with curly brackets. They always start off with curly brackets. If it's domain, we're talking about the x value, so we're going to write x. And then we're going to write just this straight line. It means, like, in proofs and things like that, x such that. And we're going to put the lowest or the furthest point to the left, which we found was -4. Then this notation is always going to be the same. It's always going to be less than or equal to, unless it's an open circle. X, which is less than or equal to. Now we have to go back and find the right side. So back on your graph, we're going to switch sides. So now make your right side go to the y-axis. And your left side go to the edge of the right of the graph. How far to the right does the graph go? On the right side, +4. So that means in our domain, that last number is going to be 4. And we're going to end it with curly brackets. So every time we write our domain or range, it's going to look like this, where we find our x and y, our furthest point to the left, our furthest point to the right, and we write it out like this. Before we find the range, what questions do we have? Now, the foldable is here to kind of help you get rid of some of the lines. As we start to do this more, if you would rather not do that and just look at the graph, you can also do that. Right? Now we're going to look at range. So we're going to take the top and bottom. And let's do our lowest point first. So take the top and put it up against your x-axis. And the bottom, where the bottom of the graph is. So it'll look somewhat like this. How far down does this graph go? -1. So wherever you wrote your domain and range, we're going to start our range now. It's going to look very similar to the domain, but also a little different. So still the curly brackets, but because it's range now we're dealing with y, so this has to be y such that, or the line. Our lowest point is that -1, still using the less than or equal to symbols. In the middle we would put y, and then another less than or equal to. Then we have to go find our highest. So switch, put your bottom flat up against the x-axis, and your top where it ends. Because it ends like at the top of the graph, it will look something like this. And count up. How far did this graph go up?
8.
As you see, sometimes the numbers aren't the same, sometimes they are. It really depends on the graph. After you have your domain and your range written, take that graph and glue it somewhere around your written domain and range. We're not going to go through all of these together. You'll have time to do some of that. But we're going to go through some of them and then move on to the others. If any of your glue sticks have dried out, let me know. After you've glued that one in, find your example number one from that same page, cut that out, and put it in your little foldable. Yeah, that way you know which one to refer back to it as. Somewhere on your pink sheet, go ahead and write domain and range, if you haven't already. Does not matter whether we find the domain or range first. I just usually find domain first, just because. So if we're finding our domain, let's put the left side up against the y-axis, your right side up against the furthest point to the left. How far to the left does this go? Emma? I believe that is what it was. So it's going to start off the exact same way. Curly brackets, x such that -7 is less than or equal to x, which is less than or equal to, anyone already find the right side? Yeah. It's also 7. Sometimes they are the same, sometimes they are not, so don't assume it to be the same, because then the count could be off. Okay. For your range, I'm not going to do the flaps, only because it's not moving. It's at just one straight line all the way across. Because it's at one straight line, it only has one y value. What is that y value? Gina. 3. So we would write this as, still start off the same way, curly brackets, y such that. But because there's only one place it ever touches, it ever equals, this would be y equals 3 in curly brackets. After you have your domain and range written, you can go ahead and do that graph and cut out example 2. While you're gluing/cutting, do you have any questions so far on the 2 we've done? So this little sheet that we're doing will be nice when you have to do domain and range practice. You can use this as a reference sheet on all your domain and range problems. Some of you may have already started working on 2, which is fine. Whether you're using the foldable or not, does not matter. What is the furthest point to the left? So now I'm not going to be using the foldable, but you still can, and if you need me to show how to do that, just let me know. But now I'm going to talk through what would happen if you weren't using it. What is the furthest point to the left for your domain? So either using the foldable or just counting.
-6.
Is that what you said, Virginia? Okay. -6. So if you haven't already, make sure you write domain and range somewhere on your pink sheet. And I would start writing this. How would I start writing this? What did I say? Otis.
Curly brackets x, straight line -6 is less than or equal to x, which is less than or equal to 6.
Right. And 6 was the other side?
Yeah.
And then curly brackets at the end. Right. Now let's find the range. So before I do that. So these are the questions you would ask yourself. What is the furthest point to the left? What is the furthest point to the right for your domain? For your range, you would ask, what is the lowest point? And then what is the highest point? So for here, what is your lowest point? -3. So how would we start writing that?
Curly bracket y -3 is less than or equal to x.
Would it be x?
I mean y, sorry. Less than or equal to 3.
So if we ask ourselves what is the highest point, we go up 3, that is our highest, and then curly brackets. Otis?
So you said domain is how far it is to the right?
Furthest point to the left, furthest point to the right. range would be lowest point to highest point. So think about it like a book. Domain is left to right, but range is lowest to highest. Alright, if you already started cutting out example 3, we're going to skip some. Cut out example 5. If you already cut out example 3, you can still do it or do that one, that's fine. We're going to do example 5, and then we're going to skip to the next page. So example 5 right now. Amina, do you have scissors and glue? Okay, you can grab one of each. Okay. On the line graph page, cut out example 5. After we do this example and then the other page, you'll have time to do some of these on your own or with each other. So if you want to cut out the entire graph, number, and the domain and range so you don't have to write it again, you can do that. If you're using the foldable, I wouldn't suggest that because the domain and range part won't fit. Right. And then Amina, put on your pink sheet, open this up. And put your graph in the middle. Right? Find your furthest point to the left. Otis? Did we all get -4? Yes, I see heads nodding. And then what is your furthest point to the right? Oh, 4. So we said -4 and 4. Yes. And then okay. So -4 and +4. Someone tell me how to write that one.
Less than or equal to x, less than or equal to 4.
Okay. And then find your lowest and highest. Give me 1 second, and after you find it, I'll answer that.
Would you have done it this way if she told you? Or this is
What was the lowest point? Otis, what did you get? -7. Did we all get -7? And before I start writing, what is the highest point? Emmett? +7. Is that what we all got? Yes. Okay. So how would we write that for our range? Anyone? How would we write that for our range?
One, or curly brackets.
Curly brackets.
One is straight line. So, one.
Curly brackets. Right? So these are different than how we're going to do the next page. So on the back of your pink sheet, we are now going to start the other page where it's like no graphs, just arrows. Cut out the example.
So I was gonna get a big one. I almost. You're running.
Alright, so with the example, first off, what do you notice? What's different between this one and the previous one, Regina?
It's not like really a graph like that. No, it's not.
There's no grid lines. What else do we notice? There's something here that wasn't on the previous ones, Regina.
Arrows instead of.
Correct. So that's going to be the main difference here. These don't have grid lines, and these have arrows instead of endpoints, which means we're not ending. It's going to keep going. So anytime you see arrows, think about it like it's going to keep going off the page, off the example, off the graph, forever and ever in one direction or the other. If it does that in both directions, so like for our domain, this keeps going off the graph to the left, think about it like it's going up and left forever and ever. This one keeps going up and right. So if it keeps going if it keeps going left and right in both directions, we write the domain like this. Still curly bracket X line. That part is the same. But if you have arrows going in both directions, we write X, this weird E, I mean, it's an element of all real numbers, but we use this symbol for R. So I just drew like a capital R with another line through it. So anytime we have arrows going in both directions, that's what we're going to write. If arrows are only going in one set of directions, like it's only going right, only going left, up, down, that's not what we would write. Okay. Questions about domain before we do range? For these ones, we don't have to like find numbers because it's going to keep going on and on forever and ever. We'd have to put every single number we know in a list of numbers, and that would take way too long. Right? For our domain, we can find our lowest point because it starts at the x-axis. What is our y value on the x-axis? 0. So it starts at 0, and then these arrows means it keeps going up and up and up forever and ever. It does not stop. So it's going to start at 0 and keep going toward infinity. So we would write that like this. Still curly brackets, y line. We can say that this graph is everything greater than or equal to 0. So y is greater than or equal to 0. That's how we would write it. Yes?
How did we get x?
We're going to do another example with that, and I'll re-explain that then.
Is that an E?
Yeah, it's an E and then R. It means element of and all real numbers. Okay. Other questions on domain or range? Do that if you haven't already. Cut out example 1. I'm sorry, cut out number 1. This one you don't have to put in the foldable. You can straight go ahead and glue it down. Okay. If we were finding our domain, it's harder for the domain because you can clearly see whether it goes up or down. Domain, you have to kind of imagine what the direction is doing, what is happening. So here, this is going to keep going down, and it's also going out to the left. So slowly it's going to keep going like this. Keep going down and left. For the other side, this is going to keep going up, but as it's going up, it's going to keep going out slowly to the right. So because it keeps going left and it keeps going right, that's going to be another example of all real numbers. That's what that's called, all real numbers. So we would write that as our domain. You could also ask yourself, what is the furthest point to the left? We don't know it because it keeps going. What is your furthest point to the right? We don't know it because it keeps going. If you don't know both, that's all real numbers. So for your range, what is your lowest point? Does it stop at 0? That's not the lowest. Do we know what the lowest is? No, because of the arrows. It keeps going down forever and ever, off the page, off the smartboard, through the floor. It would keep going on. What about the highest point? Do we know what that is? Also no. So what would the range be? It is the same, except for y. So it is also all real numbers, which happens sometimes. So I can say this went left and right forever and ever in both directions. This went down and up forever and ever in both directions. And because of that, both the domain and the range were all real numbers. All right, cut out example 2. And I'll let that be a your decision if you want to use the foldable or not. Right, for our domain, what is our furthest point to the left?
Notice.
We don't know. It's going to keep going down and left forever and ever. What about our furthest point to the right? Otis? Same. So if it keeps going left and keeps going right forever and ever in both directions, it's all real numbers. And we would write it the same way. Curly brackets, x such that x is an element of all real numbers. Is how that's read, actually. Range is going to be a little different. What's our lowest point? Otis? Is that the lowest or is it the highest? Or neither? So y values. Does this stop or start at 0? No. So what's our lowest point? That's only if it goes in both directions. Do we know what our lowest point is? No. So we know it keeps going down forever and ever. What's our highest point? 1. Not 0, because we're looking at our y value. So it stops at 1. So is it everything above 1 or everything below it? Below. So we would write that as curly brackets, y such that y is less than or equal to 1. Glue that one down if you haven't already. We're just going to do 2 more of these examples and then I'm going to let you practice on your own. Cut out example 3. I may have misspoke. We're going to do 1 more and then I'll let you do something else. Let's talk about our domain first. What do we think our domain is going to be? I see your hand. I'm just trying to get it. Anyone want to take a guess? No, not yet. All real numbers because it keeps going both ways. So that has to be the indicator. It has to go both ways, otherwise it's not all real numbers. Now this number 3 is very similar to the example 1 from the back or the other page. Is your y value moving? No, it's staying the exact same at that line. So it's going to be a y equals what? 1. So curly brackets, y such that y equals 1. Okay. On the arrow page, cross out 8 and 9. I'm going to write it up here for you, but you won't see any like that. So if you want to write it just because, you can, but you don't have to do those two. I also forgot how I was going to write that. So I'll put that up there so you have it. For the remainder of class, I want you to finish all of these examples. So do domain and range for both the arrows and the grid lines, except for 8 and 9, unless you want those on your page. Work together, ask each other questions. If you need my help, I'll be around.
That's kind of sad. I don't even know.